Pattern.
A rendering pattern.
Think of it as like the basic method a website uses to take all its code and data and actually turn it into the page you see and interact with.
Gotcha.
And choosing the right pattern. That choice, it has a huge impact on everything, really. How fast the page loads, user experience.
Even how easily search engines find the site.
Exactly. Performance, SEO, all of it.
Okay, so this sounds pretty important, and we've got a great source to help us unpack this, right?
We do. It's a YouTube video from the Beyond Fireship channel. It's called 10 Rendering Patterns for Web Apps.
Perfect. So our mission for this deep dive is basically to explore these 10 different ways websites get built and displayed.
Yep.
We'll break down what they are, how they actually work, and why understanding this stuff is kind of valuable for anyone who uses the internet.
Whether you're a developer or just curious.
Exactly. Tech whiz or just wondering how things tick.
And hopefully by the end, terms like SSR or hydration, they won't sound like, complete jargon.
Right.
You'll sort of grasp the strategic thinking developers put into this, the trade-offs they're always weighing up.
Sounds good. Okay, let's dive right in then. The most basic starting point, static websites. What's the core idea here?
Well, in essence, a static website is it's a collection of HTML files that are already made, pre-prepared.
Pre-prepared? How so?
Imagine you, build each page of your website completely on your computer first.
Oh, okay.
Then you just upload those finished HTML files to a server. That's it. So when someone clicks a link to one of your pages, the server doesn't think, it just grabs that exact file and sends it straight to their browser.
So it's kind of like the digital version of just handing someone a flyer or a printed document.
Pretty much, yeah.
The server isn't doing any, construction work on the spot?
None at all. The file's ready to go.
Now, the video mentions some tools. Hugo, 1180, Jekyll. What do they do?
Right. Think of those as helpful toolkits. They make building static sites much more efficient, especially if you have more than just a handful of pages.
Because doing it all by hand would get tedious.
Exactly. Manually creating and updating tons of HTML files, no fun. These frameworks let you use templates, manage your content neatly, maybe using markdown files or something, and then they automatically generate all those final static HTML pages for you. Kind of like an assembly line.
Got it. So the big plus here must be speed then, since the server is just handing over finished files.
Precisely. Speed is the name of the game because the HTML is already fully formed, just sitting there waiting. The browser gets it almost instantly, so that means incredibly fast loading times for the user.
Right.
Plus, they're usually very simple and cheap to host. Often just need basic file storage.
But I'm sensing a but coming. This simplicity.
Yeah.
It must have limits, right?
You nailed it.
You can't really have constantly changing news feeds or personalized dashboards with a purely static site, can you?
That's the key limitation, absolutely. Static sites are fantastic for content that doesn't change much.
Like what?
Oh, personal blogs, documentation sites, maybe a simple portfolio, stuff like that.
Okay.
But if you need data that updates all the time or user interactions that change the page without a full reload or anything personalized, static just won't cut it.
Okay, that makes sense. So from that static world, we move to something more dynamic. Multi-page applications. MPAs. This sounds like, like how most of the internet used to feel, maybe.
That's a really good way to put it, yeah. With MPAs, the HTML and the data for each page, they're generated on the server every single time your browser asks for a new page.
Every time?
Every single time. So you click a link, browser sends a request, server thinks about it, grabs data, builds the HTML for that specific page, and then sends that whole new HTML document back.
The video mentioned Amazon.com as an example.
Right.
Every time you click a product or a category, you see that little loading spinner, and it feels like a whole new page is coming in. That's an MPA.
That's exactly it. That full page reload you see with each click, that's the classic sign of a multi-page application.
And there are big frameworks for building these.
Oh yeah, a long history. Things like Ruby on Rails, Django, Laravel, even popular CMS platforms like WordPress fundamentally work this way.
Okay, so MPAs definitely handle dynamic data. That's a clear step up from static.
For sure.
But the video hinted that this approach started to feel a bit well, old. What changed? What pushed things forward?
It was really the rise of smartphones and those early native mobile apps.
Ah, okay.
Think about how smooth those felt, right? Seamless transitions between screens, super responsive.
Yeah, totally different feel.
Exactly. And compared to that, the full page reloads of MPAs started to feel, like the video said, clunky.
Clunky, yeah.
It just wasn't that fluid, app-like experience people were starting to get used to and expect.
And that leads us right into the next one. The single page application, or SPA. This was the big reaction, trying to get that smooth, app-like feel inside the browser. How do SPAs pull that off?
Okay, so with an SPA, the first thing you load is basically a single HTML page. Often it's pretty minimal, like the video said, almost a blank canvas or a shell.
Just a basic structure.
Right. And then everything else, building the UI, fetching data, happens inside the browser using JavaScript.
All in the browser.
All in the browser. So when you click to go to a different section or a different route, as they call it, JavaScript jumps in, changes the UI right there on the screen, grabs any new data it needs with separate background requests, and crucially, it does all this without making the browser reload the entire page.
Ah, so that's why when you use something like, say, Gmail or maybe Twitter, clicking between your inbox and sent mail feels instant.
Exactly.
It's not reloading everything.
Precisely. That feeling of speed and responsiveness within the app, that's the main advantage of SPAs.
But, like always, there are downsides.
Yeah.
The video mentioned some big ones.
Yeah, definitely some significant drawbacks came with SPAs.
What were the main problems?
Well, first, the initial load could be slow, because all the code for the UI, potentially a lot of JavaScript, needs to be downloaded and run by the browser up front.
Right.
That could mean a big initial download, making the site feel slow to start.
And the other big one was SEO, right? Search engines?
That was a huge one, yeah. Search engine optimization. Because that initial HTML shell was often so empty.
Just the basic structure.
Exactly. Search engine crawlers historically had a really hard time figuring out what the page was actually about, because all the real content was filled in later by JavaScript.
Which is bad if you rely on Google to find you.
Critical point, yeah. If organic search traffic matters, or even just getting previews right when sharing links on social media, those traditional SPA SEO problems were a major headache. The server wasn't sending the full picture initially.
Okay, so let's recap quickly. Static, simple, fast, but not dynamic. MPAs, dynamic, but with those clunky page reloads.
Yeah.
SPAs, smooth feel, but slow initial load and SEO issues.
Pretty much sums it up.
So now we start getting into the patterns, trying to mix and match the best parts, starting with server-side rendering, SSR. What's the idea here? Trying to get the best of both worlds.
That's exactly the goal. SSR tries to bridge that gap between the snappy feel of an SPA and the traditional strengths of server rendering.
How does it do that?
The basic idea is this. The server renders the initial HTML for the page, including the important data, kind of like an MPA does.
Okay, so the server sends real content first.
Right, which immediately helps with that SEO problem because the search crawler sees the fully formed content straight away.
Makes sense.
But then, after that initial HTML is loaded in the browser, client-side JavaScript kicks in and essentially takes over. It turns that static HTML into a fully interactive SPA.
And there's a specific term for that JavaScript takeover part, isn't there?
Yes. Hydration.
Hydration, okay. What does that actually mean? Like adding water?
Kind of. Think of it like bringing the static HTML to life. The server gives you the skeleton and the initial paint job.
Right.
Then the JavaScript that downloads to the browser adds all the moving parts, the buttons that work, the dynamic updates, all the interactive bits that make it feel modern. It attaches the event listeners and connects everything up.
So it's hydrating the static structure with interactivity.
Exactly, making the pre-rendered HTML interactive.
And the video mentioned these meta frameworks like Next.js, Next, SvelteKit being popular for SSR. Why meta?
Good question. Think of them as frameworks built on top of other frameworks.
Okay.
They take a core library like React or Vue or Svelte and add a whole layer of like prepackaged solutions and conventions for common web development headaches, like SSR.
Especially things like SSR, yeah. And routing, how you move between pages, build optimizations, stuff that's tricky to set up from scratch. They bundle it all up nicely.
Saves developers a lot of work, I imagine.
A huge amount of time and effort.
So, the video said SSR is pretty popular right now. Why the appeal?
It just offers a really strong combination, you know. You get much better initial load performance in SEO compared to a pure client-side FBA, but you still get that fluid, interactive experience once the page is loaded and that hydration process is done.
Sounds great, but nothing's perfect. The video mentioned needing a server.
That's the main trade-off, yes. Unlike a static site, SSR needs an active server environment, something that can actually run code and dynamically generate that HTML for every request, which means server costs, more complex deployment, potentially thinking about scaling that server infrastructure. It's not just simple file hosting anymore.
Got it. Okay, moving along. Another pattern focused on speed and SEO. Static site generation, SSG.
How is this different from SSR, or even those original static sites we started with?
Okay, SSG takes that idea of pre-building HTML even further. Remember how SSR builds the page when the user requests it?
Yeah.
And basic static just serves files that were already there?
Right.
SSG builds all the HTML for your entire website at build time before any user even visits.
At build time, so when the developer is like compiling the site?
Exactly. When you deploy your site, you're uploading a complete set of fully rendered HTML pages ready to go, usually to a static hosting provider.
Well, wait, the video also mentioned hydration with SSG.
Yes.
And Jamstack. So it's not just plain HTML in the end.
That's a really important point, yes. While the initial HTML is static, super fast to serve, SSG sites very often include JavaScript that adds interactivity after the page loads, very much like SSR's hydration. So you get this powerful mix, the speed, simplicity, and low costs of static hosting, but with the potential for rich dynamic features added by JavaScript later. That whole architecture, JavaScript, APIs, and pre-built markup, that's what people often call the Jamstack.
And those same meta frameworks, Next.js, Nuxt, they handle SSG too.
Absolutely. They're usually quite flexible. They let developers choose SSG, SSR, sometimes even mix them within the same project.
Versatile. Okay, so SSG sounds pretty good too. Fast, cheap hosting, still potentially interactive. What's the catch?
The main limitation is dealing with updates.
Updates.
Yeah, because all the pages are generated upfront at build time. If your underlying data changes, like a new blog post goes up or a product price changes,
what then?
You typically have to rebuild and redeploy the entire website to get those changes live.
The whole site. Every time something changes?
Often, yes. For really large sites or sites with data that changes very frequently, that full rebuild process can become slow and inefficient. Oh, okay. I see the problem there. Which leads us very nicely to number 6, incremental static regeneration, ISR. This sounds like a clever fix for that SSG update issue. How does ISR work?
It is pretty clever. ISR, which, the video correctly credited Next.js with pioneering, kind of builds on SSG. You still deploy a mostly static site.
Okay.
But here's the twist. You can tell certain pages, hey, even though you're static now, check for updates every so often.
And check for updates.
You configure them to be regenerated in the background on the server, maybe every 10 minutes or once an hour, or maybe triggered when specific data changes.
So instead of rebuilding the whole site like standard SSG,
exactly,
it can rebuild just individual pages sort of behind the scenes.
Precisely. Think of it like this. You serve the fast static version most of the time, but the server has this background task that can periodically rebuild that page if its cache is considered stale based on the rules you set.
And the next person who visits gets the fresh version. Yep.
After it's been regenerated in the background, the next visitor gets the updated content, still served statically and quickly.
That sounds like a really neat compromise. You get the static speed and low cost for most users, but you can still handle dynamic data without needing a full-on SSR server running constantly.
Exactly. It hits a really nice sweet spot for many websites, offers a great balance.
But again, trade-offs. The video mentioned complexity.
Yeah, it's definitely more complex to set up and manage than basic SSG, and often it works best, or might even require, a hosting platform like Vercel, which built Next.js and has native support for how ISR functions.
Okay, interesting. So we've covered the main strategies for getting pages built and delivered. Now the video shifted focus a bit, right? Towards optimizing performance, especially for these hydrated apps, the SSR and SSG sites using JavaScript.
That's right. Focusing on the user experience after the initial page load.
First up was partial hydration. What's the problem this is trying to solve?
The core issue is that even with SSR or SSG, sending that initial HTML fast.
Yeah. The browser still has to download, parse, and run all that JavaScript to hydrate the page and make it interactive.
Right, that hydration step.
And on big, complex sites, that can take a noticeable amount of time. Milliseconds, maybe seconds. Which leads to that frustrating feeling where the page looks loaded, but you click a button and nothing happens.
Yeah. The page feels frozen for a moment.
Exactly. It's loaded, but it's not interactive yet.
So partial hydration tries to fix that specific frustration.
It does. It basically asks, Do we really need to hydrate everything on the page all at once, right at the start?
Good question. Probably not.
Probably not. Like on a long blog post, maybe the JavaScript is busy hydrating the comment section way down at the bottom, which the user hasn't even scrolled to see yet.
Wasting time on invisible stuff.
Kind of, yeah. Wasting precious time making things interactive that the user doesn't need yet.
So partial hydration, it prioritizes.
Precisely. The idea is render and hydrate only the components that are immediately visible in the user's browser window first. Make those interactive quickly.
And the rest.
The JavaScript for the other component stuff further down, less critical things, can be loaded and run later, maybe when the user scrolls them into view or clicks something related.
Makes the site feel usable faster.
Exactly. Improves that perceived performance. The video also mentioned code splitting quickly, which is related breaking your JavaScript into smaller chunks loaded only when needed.
Got it. Okay, next optimization pattern. The islands architecture. Sounds exotic.
Yeah, it does sound kind of cool.
How's this different from partial hydration?
It takes that idea of being selective about interactivity a step further, maybe with a slightly different mindset.
Okay.
The core idea of islands is you start with a base of mostly static HTML. Think of that as the ocean.
The ocean, right.
And then embedded within that static ocean, you have specific isolated interactive components. These are the islands.
Islands of interactivity in an ocean of static HTML.
You got it. And only these designated islands get hydrated with the JavaScript.
So wait, does that mean large parts of the page could be pure static HTML, even if I built them using, say, React or Vue?
That's the really powerful insight, yes. If you have a big chunk of your site that's just static content, like a news article, mostly text and images, and you use a framework designed for islands, like Astro, which the video mentioned,
Astro.
you might actually ship zero JavaScript to the browser for those static parts, even though you, the developer, used a JavaScript framework to build it.
Wow. Zero JavaScript.
Potentially, yes. Only the truly interactive bits, maybe a navigation menu, an image carousel, a comment form, only those islands get the little bit of JavaScript they need to function.
That sounds incredibly efficient. Could lead to super fast sites, especially for content.
Absolutely. Much less for the browser to download, parse, execute. It's a very performance-focused approach that's gaining a lot of traction.
Very cool. Okay, nearly there. Number 9, streaming SSR. We talked about SSR already. What does adding streaming do?
Streaming SSR is all about making regular SSR feel even faster to the user, improving that perceived performance again.
How so?
Okay, in traditional SSR, the server usually figures out the entire HTML for the page first, puts it all together into one big string,
Right.
and then sends that whole completed document to the browser.
Makes sense.
With streaming SSR, the server can start sending pieces or chunks of the HTML to the browser as they become ready, rather than waiting for the whole thing to be finished.
So the browser can start painting the screen sooner, while the server is still working on other parts.
Exactly. The user sees visual content appearing earlier. Parts of the UI might even become interactive sooner because the browser isn't just sitting there waiting for one giant HTML file. It can start processing the incoming stream.
So it feels snappier.
Significantly snappier, potentially. The video mentioned frameworks like Next.js 13 using things like React Server Components have built-in support for this. It's a really nice optimization on top of SSR.
Okay, that makes a lot of sense.
Yeah.
And finally, pattern number 10, resumability. The video called this a novel paradigm, pioneered by the Quick framework. And the goal, eliminate hydration altogether.
Yeah, that's the big, bold claim. It's a fundamentally different approach.
Eliminate hydration? How on earth does that work?
Okay, so instead of server HTML Zoo client downloads js.client runs js to hydrate.
Right, the SSR SSG model.
Resumability tries this. The server sends HTML, but it serializes the entire state of the application, including things like event listeners, right into that initial HTML.
Whoa, it puts the instructions for interactivity in the HTML itself.
Kind of, yeah. All the essential info about how components should behave, what their state is, what should happen on a click that's encoded directly in the HTML somehow.
Okay, then what about the JavaScript?
The JavaScript code is broken down into incredibly tiny, hyper-specific little chunks.
Tiny jumps.
Super tiny. And they're lazy loaded. So when a user actually interacts with something, clicks a specific button, for example,
Yeah.
only the minuscule piece of JavaScript absolutely required to handle that exact interaction is downloaded and executed just in time.
So there's no big upfront hydration process making the whole app interactive.
Correct. There's no phase where the client has to re-execute code to connect listeners in state. The interactivity is essentially resumed directly from the information serialized in the HTML.
And the benefit.
The potential for extremely fast initial loads, almost like static HTML because there's no hydration bottleneck, but you still get rich interactivity, fetched just when needed. It's genuinely trying to solve some deep-rooted performance issues in modern web apps.
Wow. Resumability. That's a really different way to think about it.
It really is a cutting-edge approach.
So 10 rendering patterns, that's quite a journey from just thinking a web page appears. It's definitely more complex than that warning in the video, right? Learn web development, it'll be easy.
Yeah, absolutely not. What's fascinating, though, is seeing how each pattern evolved. Each one tries to fix a problem with the previous ones or optimize for something different.
Like speed or SEO or interactivity.
Or developer experience, even hosting costs. It shows there's no single best way. It always depends on what you're building, what your priorities are.
Definitely. And it really highlights that the websites and apps we use every day, the ones that feel so simple, there's often some seriously sophisticated thinking and engineering underneath. So hopefully for everyone listening, this deep dive gives you a clearer picture of why different sites feel different. That slight delay you sometimes hit.
Or that super fast navigation on another site.
Exactly. There's likely a specific rendering pattern making that happen.
Which maybe leads to a final thought for listeners to chew on.
Yeah.
As you browse the web now, using different services blogs, e-commerce sites, complex social media apps, start thinking.
Yeah.
Which of these patterns might be powering this experience? Why might they have chosen that one?
Interesting exercise.
And looking forward, with how fast web tech changes, what's the next evolution? What new patterns or refinements might emerge to make things even better, faster, smoother? It's constantly evolving.